Hello and welcome to Variety Hour. I'm Alex Rude from the WILDLABS community team, and I am going to be your host for today. It's October Variety Hour, which means that it's sort of a Halloween themed, and we're super excited to have our speakers here today. We have some awesome, great speakers lined up today, as well as a secret and maybe even spooky Halloween-themed quiz from our quizmaster, Henry Reese. And our speed talks today are from Lars Holst Hansen, Seamus Lombardo, Phil Atkin, and Jessie Kendall-Bar, who will be wrapping things up with a longer talk. So first, I'm going to pass it over to Lars to kick things off by telling us about PolarBearWatchDog, which is an AI-driven polar bear detection system. So Lars, you can take it away.
Okay, I'm going to give a very brief introduction to PolarBearWatchDog, which is a polar bear alarm system under development. It's based on IP cameras and a central processing with single board computers. We're making this alarm for Sagenberg Research Station in Greenland, and here I spent 3 to 4 months every year doing ecosystem monitoring. In the last 15 years, we've had an increasing number of polar bear encounters and also visits to the station. If the system works well, we want to make it available to other stations and also Arctic communities. We're basing the alarm upon Kim Hendricks' home security system called Stalked by the State. I met Kim here on WILDLABS as he wanted to use his system for wildlife, and we teamed up for this project. The core of the system is a single board computer cycling through input streams from IP cameras and doing all the processing centrally. It has shown very stable and has been continuously used for home security at multiple locations for the last 13 years. It is extremely flexible with regards to inputs, but also outputs to alarms, relays, alerts to phone, email, etc. And it's also relatively powerful compared to other edge devices. That means it can run rather powerful and large models with hopefully better detection. This spring, I set up a hardware test in the zoo in Copenhagen, started to collect footage. And as you can see, off-the-shelf model like YOLO version 6 works very nicely, but it also has many pixels to work with. When we pressure test it, it struggles a bit more, but it's not very surprising given the very loosely defined bear class definition in the COCO dataset, which includes teddy bears and even gummy bears. Yes, I kid you not. Therefore, an important part of this project is also to make a quality and diverse data set for training. And we want to make this publicly available at a place like Lille, BC. And collaborating researchers from around the Arctic are helping with gathering this data. One thing we want to try is to explore methods to increase the detection range by use of so-called sweeping crops. And this way, a fixed wide-angle camera can actually work as a panel tilt zoom camera, casting more pixels on distant targets. Next year, I will field test the system in Greenland, and we will think hard about how to cover the station with a combination of fixed cameras, but also use the panel tilt zoom we have. If we need more computing power, it can actually very easily be upscaled with larger single board computers or even a desktop with graphical processing units. However, it can also be downscaled to smaller devices like the Jetson or Nano, for instance, or Raspberry Pi, for which Kim has also made a version. And I would like to test it with 360-degree cameras to do a very highly mobile system, which I have nicknamed the Polar Bear Watch Puppy. Finally, I have a call for collaboration. If anyone has polar bear footage they want to share and contribute to the dataset, if they have ideas for test locations, or if they would like to have their edge devices tested in a high Arctic environment, please don't hesitate to contact me. If they have technical questions or other ideas for other use cases, Kim Hendricks is the guy to contact. Thank you very much.
Well, thank you so much for that talk. And I fear that you might have done too good of a job timing yourself because you are under time and even leaving some time for questions.
That's fine.
Which is fantastic. So the question I have for you and everybody else, I encourage you to drop any questions that you have in the chat, is after hopefully when people contact you to have these collaborations, what are you expecting to come out of that, and sort of what are you most looking forward to in terms of like application in the field post collaboration?
I'm not sure what you mean.
So you're asking people to come to you with for collaboration with more footage, with ideas for test locations for testing their devices. What are you hoping comes out of that collaboration?
Well, that we make a super nice system that can be used like in other places, and hopefully in the local Arctic communities, villages, and so on, where they might find this very useful.
Got it. So the goal is to stay within the Arctic sort of ecosystem, keeping it
Yes.
polar bear watchdog and not so jaguar.
Yeah, but I know Kim has a lot of other ideas also, because this system has very high potential.
Nice. Well, thank you so much for that talk. It looks like we have a few other questions in the chat, so I'm going to direct you over there to get those answered. Thanks again. And then now we're going to move on to Seamus. Seamus Lombardo is going to be introducing us to Planet's project Centinela. Sorry, I practiced this beforehand, which is being used to monitor vulnerable biodiversity hotspots. So Seamus, it's all yours.
Great. All right. Hi, everyone. I'm Seamus. Today, I'm going to be presenting on Project Centinela, but first, I'm going to start off with a little bit of background about Planet itself. So Planet is a company that builds and launches satellites, and our mission is to image the entire world every day to make change visible, accessible, and actionable. And so how do we do that? Well, Planet has two main satellite constellations. The first is PlanetScope, which is hundreds of breadbox-sized satellites imaging the entire Earth's landmass every single day at 3.7 meters per pixel. This is then augmented by our SkySat satellites that operate on a tasking paradigm and take images of more focused locations at 50 centimeters per pixel, even higher resolution. And we can leverage these different satellite data sources to look over broad areas, look backwards in time at a near daily cadence for several years, really zoom in for super high resolution images with the SkySat constellation. And we also have these products called Planetary Variable Analytics, where we combine our imagery with other satellite data sources like LiDAR or microwave to provide insights on things like soil moisture or canopy height and forest carbon. As a public benefit corporation, we create these programs that we call digital public goods, or putting data in the hands of the end user at no cost to that end user. You might be familiar with some of these existing programs like the NICFI Satellite Data Program, which makes that PlanetScope imagery available for free for preventing tropical deforestation. I'm really excited to share with you today about our newest digital public good, Project Centinela, which is a biodiversity hotspots monitoring program. And Project Centinela is set up as an open application for 50 biodiversity hotspots around the world to receive data grants for biodiversity monitoring. And what are we looking for in these hotspots themselves, the physical locations? Well, we're looking for sites of high conservation value with a risk to biodiversity. We're seeking to prioritize underinvested ecosystems, and we're limiting these data grants to the landscape or the seascape scale. So think a national park or community reserve under 15,000 square kilometers. We'll also have some key criteria for the applicant teams themselves. We're looking for folks that have biodiversity expertise, at least one element of the team to have some experience with remote sensing so you can hit the ground running with our data. And most crucially, we want these folks to have a long-term stake and boots on the ground in the place identified so that we are augmenting ongoing conservation work. So what would successful applicants actually get access to under this program? Well, it would be almost our entire product suite here at Planet. So that PlanetScope, near daily imagery at 3.7 meters per pixel, SkySat, focused tasked images at 50 centimeters per pixel, Planetary Variables, synthesizing multiple sources to provide insights on things like forest carbon, land surface temperature, and soil moisture, machine learning algorithms applied to our data for things like monthly road detection, and access to our cloud computing platform where you can do things like spectral analyses and time series analyses. Here's an example of folks that we already work with that leverage all these different data streams for conservation work. This is our partner, Just Dig It, who works with desertified communities in East Africa to build water capturing bunds to help promote vegetation regrowth. In the top right, you can see that our imagery, that 3.7 meter PlanetScope imagery, shows the vegetation regrowing over time in these bund areas. But these planetary variable analytics also quantify that as the vegetation regrows, the soil moisture increases and the land surface temperature decreases. So this is what we hope folks in Project Centinela can do: leverage all our data sources to quantify and maximize the impact of your restoration or conservation interventions. So just to give you an initial taste of what we're looking for in Project Centinela, our first 8 sites span multiple continents and multiple ecosystems. And I'm just going to highlight 3 of them now to give you a flavor of some of the folks that are successfully applied and are also using conservation tech. So, for example, in Latin America, OSA Conservation in the OSA Peninsula in Costa Rica is using our data in a project to establish wildlife corridors and monitor habitat restoration, and combining it with their conservation tech of camera traps and GPS tags for wildlife. In Africa, we're working with the Wildlife Conservation Society and Nature Metrics on a project focused on creating new marine protected areas and informing community fisheries. And the conservation tech angle here is that we're trying to develop operational workflows to synthesize our satellite data with their eDNA data that they're collecting in this marine ecosystem. And our last example here is we're working with Wildbon and Planet Indonesia in Borneo to support the creation of new take zones and empower local ecosystem stewards by combining our data with bioacoustics and camera traps on the ground. So with that, I'll conclude, and we encourage you and your partners to apply for Project Centinela.
Thank you so much. A few questions. One, is it okay if people reach out to you with any questions, following this call about
Yeah,
specific
absolutely. And I'll also drop the application link here in the chat.
Fantastic, thank you. One question I have is, obviously you mentioned like some of those example projects of combining satellite data with field data like eDNA or animal movement, bioacoustics, camera trap data. Are there any other types of field data that Planet is like specifically looking to integrate with its satellite data, or, and I guess are is some of that data harder to combine with satellite data than others?
Absolutely. So we're definitely looking for any on-the-ground information that folks feel is relevant to their workflows. Satellite data can be really powerful for measuring things like ecosystem extent and even ecosystem condition as it relates to like vegetation phenology. But there's so much going on under the canopy that we simply can't capture with satellite remote sensing. And so other data sources that come to mind might be terrestrial LiDAR or even like community science. We're pursuing things with like eBird and Merlin and those kind of folks. And to your point about challenges, we view this program as very much R&D for developing operational workflows to combine those data sources. So we're eager to work with folks that have expertise on these on-the-ground workflows, and crucially, like real conservation objectives supported by that data, so that we can figure out what is the best way to augment that work with these additional satellite data streams.
Perfect. Well, thank you so much. It looks like we have some questions in the chat, so I'm going to direct you back into there to answer those.
Sure thing.
We'll talk. Now we are going to move on to our last speed talk from Phil Atkin, who in the Halloween spirit is going to be talking to us about the pipistrelle family of bat detectors that he's been developing, which was the inspiration behind the graphic design of this month's Variety Hour. So Phil, it's all yours.
So yeah, I will be talking very, very quickly about the pipistrelle family of bat detectors and recorders, which kind of came out of nowhere from my perspective. So in 2021, I accidentally became a bat person and became a bat acoustics person. We moved house in March. By April, we decided we really wanted to do something that was locally engaged. So my wife and I both volunteered to be surveyors for the Bats and Churches project. Having decided I was going to become involved in bats, I figured I just had to design my own bat detector. So in exactly 2 weeks, I got all the software running and lashed up the hardware. Clearly, something like this was never going to work on the road, so I decided to turn that into a printed circuit board. And while that was happening, we started to survey churches. Now, for the first time, I had a full spectrum bat recorder in my hand. And I had two immediate responses to that. One was, this is the coolest thing ever. You can record bats with it. The other was, oh my God, it's 350 quid. I can do one of those for 20 quid. Hold my beer. So I kicked off on initial detector 2 weeks. I'm now 3.5 years in, but I think I finally got something that I'm happy with. The electronics has all moved to the back surface. There's a 3D printed case that everything works in, and these are now actually available commercially. I don't make any money from these. All my take goes to charity. So I'm not here kind of trying to earn money. Pipistrelle 5.6, I think we're at, is paired with pippyg 3.6. Pippyg is a pipistrelle without the bat detector, so it's just a full spectrum recorder. Honestly, it's a Poundland audio moth, if any of you know audio moth, and it came out of a conversation with the Bat Conservation Trust during the Great Silicon Shortage of 2022, where somebody said to me, you can't buy an audio moth and you won't be able to for about 12 months. Why don't you just design an audio moth? So I did. They require an app to, oh, hang on, I missed a transition there. Let me go back. Yeah, so they require an app to set up recording. So sleep time, wake time, duration of recording set up with this app, which I wrote. Having got back into writing apps, I thought, I may as well write a bat detector app. So I wrote a bat detector app. This was a couple of months ago. But since my goal is to get everything as cheap as possible, this needed to have a really cheap USB microphone to go with it. So given that the innards of pipistrelle and pippyg could operate just fine as a USB microphone, I've done this. And I'm actually wearing my Griff USB microphone as a badge. So it's a 384 kilohertz USB microphone. You can build it at home for 10 quid. You can build a pipistrelle at home for about 20. You can build a pippyg at home for about 17. So that turns into like between $25 for the pipistrelle and maybe $15 for the USB microphone. So incredibly cheap. You can buy pippyg and pipistrelle commercially, £40 pre-assembled from a third-party company, Smith Robotics. Where did I go next with this presentation? Yeah, so hold on, Phil. Why were there so many iterations of pipistrelle? Was there a problem? So my feeling, back at this point, you're thinking, I have solved the world's bat acoustics problems. I've developed the most affordable recorder, the most affordable detector, the most affordable USB microphone. Brilliant. Sadly not, because I had this problem I could not get rid of, which is my recordings had noise on them, which was clearly, if you look at the interval between these little spikes, the noise was clearly associated with the SD card and writing data to the SD card. So these little spikes here, which manifest as a grinding noise on the recordings, are at exactly 16 kilobyte intervals from a recording perspective. These things are some more macroscopic artifacts, but they're all associated with the SD card. The reason being that the SD card takes a ton of current when you start writing to it. That disturbs the power supplies, disturbs the ground reference level, and that those insertions of noise into the system then become noise on the recordings. This was the thinking. So the way you defend against these kind of issues electrically is you decouple. So you throw lots of capacitors all over the board to try and stabilize the supply as much as possible. And clearly I did stabilize the supply as much as possible, and this recording noise didn't go away. So quite what was going on? And a chance conversation with Alex at AudioMoth on Twitter led to this scales falling from my eyes revelation, which is, he said to me, do you know that SD cards generate ultrasound when you write to them? They operate as piezoelectric speakers. And I thought, oh, bugger. All this time I've been chasing what was an electrical problem, and it's an acoustic problem. So the way you solve that is just to move the microphone away from the SD card, separate the card into two parts. And I only took a few days to put this design together, send off the designs to China, get the hardware back. Everything works brilliantly. Once again, I have clearly solved all the world's bat detection problems. And I was so pleased, I presented it to the WILDLABS community. And this was, so point to note, I'm not an electronics designer. So all of this was me grubbing around in the dark. And I'd spoken to electronics people and I'd spoken to ecologists, but I'd never actually managed to engage successfully with the bioacoustics community. Within about half an hour of getting onto the WILDLABS community, I had engaged with the bioacoustics community. And Harold Tay, thank you, Harold, sent this message saying, are you quite sure that it's the SD card and it isn't the capacitors that you've used? So my defense against electrical noise was to put lots more capacitors onto the circuit board. It transpires that those capacitors are much louder piezoelectric speakers than the SD card. And I've been barking up the wrong tree for like 2.5 years. So it wasn't Agatha all along, it was the capacitors all along. So replacing the capacitors with a different type of capacitor changed everything. There are two different types of capacitor you have to use. Big capacitors go to polymer tanks, little ones go to something I can't even pronounce. And hey presto, the standard pippyg now makes recordings which are as clean as the separated microphone version. And here's a before and after. Now, there's generally a swish of noise here. The noise is much lower here, but the key thing, the absolutely key thing is these clunking artifacts have entirely disappeared. And those clunking artifacts are a gigantic problem because they can be mistaken for bats by automated classifiers. And there's nothing worse than having your bat recorder generating artificial bats as an artifact and then clogging up the databases of classifiers with bad readings. So we've now reached the point, after 3.5 years, have reached the point where these devices really do make good enough recordings. They're on par with AudioMoth. They're never going to compete with your $1,000 recordings. But you can build something at home for 20 quid, which you can then deploy all over the place. And I've got, there are researchers in Spain with 70 of these things in the field that their ecologists have hand assembled, stuck into ovens, baked up, and are sampling bats in the mountains of northern Spain. And there we are. I was wrong all along. It was the capacitors. Thank you, WILDLABS community, and thank you all for listening.
Thank you so much for that presentation. I was so excited to invite you onto this Variety Hour, one, because of the bats, but also because I was sort of watching in real time between your LinkedIn and your posts on WILDLABS, conversations all happening, and that is at the heart of what we do. And it was so exciting to essentially watch it happen in real time. And he's putting on the hat, and the hat is awesome. We're a little bit over time, so I'm going to put questions in the chat for you because I'd certainly have some about bats in churches and whatnot. And it seems like we have some more questions flowing into the chat right now. So feel free to go answer those in there. And now I'm going to pass it over to Mr. Quizmaster Henry for our Variety Hour ad break. Take it away.
Excellent, thank you. Well, actually, I'm going to hand it back to you first of all, Alex, because I think there's only one thing we're advertising, which is our network survey, which is currently underway. So, Alex, please take it away.
Yes, if I haven't bothered you yet about taking the network survey, personally, I probably will within the next 24 hours. We are running this network survey essentially to get feedback from the community on how you use WILDLABS, how you engage in the network, whether that's through our event series like Variety Hour or tech tutors or virtual meetups or on our platform. And your feedback is incredibly valuable and important to us as we sort of chart the direction that Wild Labs goes in the future in terms of what features we develop on our site or what programs we run, like Women in Conservation Tech or tech tutors or funding opportunities like the Boring Fund. So I super implore you to take 12 minutes out of your day after Variety Hour, of course, because we want your full attention, to participate in this network survey and let us know what you think we should be doing in the future, what we're doing well now. And yeah, and there's a QR code right there. I'll also drop a link in the chat for easy access. And yes, please take the survey, and I will probably email you within the next day if you haven't heard from me already. Thank you.
Thank you very much, Alex. Yes, please do get those community survey responses into us, because it really helps us kind of shape what we do and make sure that we're serving the community as best as possible. But okay, we don't want to spend too much time on this because we're a bit over time, but we thought we'd break up, well, as we usually do, with the official Variety Hour quiz. So because it's officially our spooky season, Halloween is right around the corner. So we thought we'd do a Halloween themed conservation tech quiz focused on, of course, the spookiest of animals, which is, of course, bats. So, Phil, you're not allowed to answer any of these questions, I'm afraid. I think you've got an advantage, and other bat people as well. You might find this very easy, but hopefully this kind of gives some wider context to Phil's talk. So, yeah, we didn't coordinate it, but it seems like it's worked out quite well. So, yeah, all of the questions will be focused on bats, and as usual, please write your answers in the chat. I think I've got a Halloween-themed noise. Excellent. That's that Variety Hour quality right there. Okay, question one. Let's go. We're starting with a very easy one. Can you tell what species a bat is by listening to the frequency of its call? It's simple, yes or no, and this should be very easy based on what we just talked about. Yes, 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 yes. Correct. The answer is in fact yes. Okay, nice and easy to start off with. Well, question two. In the back here, you can see a visual representation, as you did in Phil's presentation, of the frequency of a bat call. And by looking at this chart, you can analyze a bat call and different species of different calls. Anyway, seems like you guys know what it is. What is this chart called? A telegram, a sonogram, a spectrogram, or a microgram? I'm seeing answer, sonogram, spectrogram. The answer is, in fact, spectrogram. And the reason why it's called that is because it is a graphical representation of a spectrum of sound. So it's kind of combining the word spectrum and gram. Yeah. Still pretty easy. So, and now we know that, how many bat species, different bat species, do you guys think have been recorded here on this spectrogram visual representation? 5, 8, 18, or 26? What do we think? People said A, 5, C, 18, 5. Alex would have said 2, but that's not an option. Matthew's saying A. Well, actually, the correct answer is 18. It's quite low, Polly, right there, but these are all, in fact, different species of bats. And you can see clearly on this spectrogram the different variation in bat calls. So yeah, bats call at different frequencies to adapt to their specific environments, you know, and also to adapt to the different types of prey that they're hunting. And for example, higher frequencies of call are much better for compact environments like a forest or a building, but low frequencies are better for open spaces because the sound travels further. So yeah, we could really get into it, but yeah, you can see there's a huge amount of variety here in the amount of different calls that a bat has. And finally, question 4, what percentage of mammal species in the whole world are bats? And you saw on the previous slide that there are certainly more, there are at least 18 species of bat. But what percentage of all mammal species are bats? 1%, 5%, 8%, or 20%? Alex said B, had a couple of Bs, had a C, an A, quite a few Ds as well. Well, let me tell you, the answer is in fact a whopping D. 20% of all mammal species in the whole world are bats, and that's over 1,400 bat species that are there. So because bats are so adaptable and they have a monopoly on the niche of being a nocturnal flying creature, they're found on all major continents except for the Antarctic. Bats are incredibly diverse. And you can see some pictures that I took here on the right of horseshoe bat here on the bottom, and a hammerhead bat up here, and that just shows the kind of extremes you get in what bats actually look like. So yeah, they're amazingly diverse and really, really cool creatures. And I think you guys seem to have learned something there, which is good. But well done to everyone who got all those right, or some of those right. Yeah, that's the end of the quiz. Just a very quick whistle-stop bat tour. And with that, I'm going to hand back over to Alex to take us on to the next speakers.
Wow. First, I need a minute to process that hammerhead bat. Because that is a crazy looking animal. Thank you so much, Henry, for putting that quiz together. I learned a lot, certainly. Wow, that image is going to be stuck in my head for the rest of the day. So we're running a little bit ahead of time, which never happens. So that's exciting. For our last speaker, for our longer talk, we are going to be having Jessie Kendall-Bar talking about how biosensors and 3D modeling are being used to track and integrate sleep and movement data. And I am super, super excited about this talk. I got a sneak peek of the presentation beforehand, and I was totally floored. So I'm going to hand it over to Jessie to walk us through that now.
Great. Thanks, Alex, for that introduction. And thanks for being here, for tuning in. I just submitted my survey in the ad break, so I'm very proud of accomplishing that. Yeah, so this is going to be a little bit different because I'm coming from more of the side of an academic, and I'm trying to tell you what I've done in my dissertation and then what I want to do in the next steps of my career, and where I would really appreciate some help from people like you that are designing new technologies and new softwares and new data packages, so that we can really learn important things about animals, specifically their physiology and behavior is what really interests me. So as I said, I'll talk briefly about the problems that I ran into during my dissertation, and then that feeds in directly to my plans for future research as I start to create a lab. So during my dissertation, I combined engineering, data science, visualization, and a bit of machine learning to look at the sleep patterns of northern elephant seals from the individual to the population level. And I think in this community, we're all on the same page as biologging scientists who are asking animals to carry our instruments into the field. We need to minimize the impact of those tags on the animals and also maximize the impact of every one of our data sets. So I worked with my intern, Ritika Mukherjee, on this literature review, and we found that the vast majority of work to detect sleep in animals has been done in captivity and with invasive methods. So our study tries to bring the study of sleep into the wild with non-invasive methods. And to design this surface-mounted sleep recording device that measures EEG, or electroencephalogram, alongside ECG, the hardest part is to make sure that each of the sensors is electrically isolated from one another. So I designed a head cap and a system for the wires to remain electrically isolated and pressure-proofed up to 2,000 meters deep, where the elephant seals could dive. And we came across some interesting, I can talk maybe for days about the different sources of noise that we came across. And it wasn't the capacitors, but lots of other technology that we need to deploy on these animals to find the tags again, like VHF transmitters, or anything with a battery and anything with a voice, whether that's electrical or sound. And then the other source of noise is actually coming from the animal itself. So the large heart of an elephant seal is actually kind of a problem when you're trying to listen to the smaller signals that are coming from the brain. So we used independent components analysis to try to disentangle what noise was coming from the signals from the heart and what noise, what was the signal that we were looking for, the signals from the brain. So we had some success in just disentangling those two. And then we had a new challenge of how to score sleep for an animal that we have never recorded sleep in the wild for. So we had to come up with a criteria for what is slow wave sleep, what is REM sleep, what is waking. And then we even came up with a new state called drowsiness, where they're sort of going in and out of slow wave sleep at a frequency of about 10 seconds. So we had to talk to experts all over the world to try to establish new criteria for categorizing sleep. And then adding physiology to the field of movement ecology, presents a whole nother challenge where we're adding essentially 18 dimensions of complexity to the data analysis challenges of movement ecologists that are thinking about animal movement in 3D, in space and time. So when we're looking at this much data, it's hard enough to make space on the screen. I'm only showing about half the signals that are recorded on this neurologger. And many of these signals are actually trying to paint a three-dimensional image. So traditional tools for analyzing this neurophysiological data that show us spectrograms alongside time series data are not usually made for measuring sleep across space and time. So I had to build my own end-to-end visual analysis pipeline to see the patterns in 3D movement alongside the animal's internal physiology and brain activity. So I talked about how we deal with the physiological data. We categorize it into these discrete categories of sleep state and respiration state. And then we have to analyze the motion and environmental sensors. So we can use some math magic to transform the raw signals of the accelerometer, gyroscope, and magnetometer into pitch, roll, and heading. And we can get an estimate of speed and use that to create a three-dimensional track using dead reckoning. And then we can paint on the labels of physiology on top of that three-dimensional image, showing us a representation of physiology across space and time. But that's not enough for me. I really wanted to see and experience the behavior and physiology firsthand. So I built this animation pipeline that uses Autodesk Maya, which is a software that is used in the movie industry. And I paired the sound to the heart rate data to get an output that really recreates a scene from the open ocean. I didn't share my sound, but you can hear the heartbeat of the elephant seal, and then it starts to go down as the animal leaves the surface. So I'm not going to make you sit through the entire 30 minutes of this deep dive for this northern elephant seal, but visualizing dives at this fine of a time scale can lead us to some really exciting new hypotheses about how these animals control their heart rate and their perfusion while they dive. In the case of this sleep study, it allowed me to interpret the seal's internal neurological patterns alongside its 3D trajectory. So this is hypoactive Heidi. I gave her a cute name so I could remember who she was. And she leaves the surface, she swims down about 100 meters, and then as she reaches about 150 meters, the slow waves start to emerge in her brain. So you can see those in the spectrogram at the top of the screen. And then there's a flip in her body posture where she turns upside down, and that enables the transition to REM sleep, where presumably she has become paralyzed about 200 meters below the ocean's surface. And she continues falling like a leaf for another 150 meters. And then at around 263 meters, she'll decide to wake up and swim back to the surface. So these visualizations are really helpful from an analytical perspective. They allow us to see that her neurological state is actually tied to her three-dimensional behavior and 3D movement, but they're also helpful to communicate our findings. So we use these animations alongside our paper as supplemental material, and our animation was actually featured by the New York Times and the Atlantic and contributed to the paper's reach in our community. And then we can use that biomechanical signature of sleep to build a detector that, that operates on simpler data. So in this case, we only have depth and time, but we're able to use that signature to estimate the amount of time that these animals are sleeping. And the great part about this is we now have access to a much larger data set. With over 300 animals, we can get a daily time estimate as they travel across the Pacific. And that leads us to an estimation of a very low sleep quota for time at sea, only 2 hours a day for up to 295 days that they spend at sea. And that's going down from the amount that they sleep on land, which is about 10 hours per day. So that degree of flexibility between 10 and 2 is unparalleled among all mammals, and raises this really important question of what is the baseline sleep requirement for an animal that oscillates between 10 and 2. So I think that it's really important to help answer some of these questions so that we can turn our focus towards conservation and inform the management of protected areas and how that's going to trickle down into the sleep and health of these animals. So overall, my dissertation used a really small subsample of high-resolution electrophysiological data to identify a proxy for sleep that we can apply over a much larger data set. And I think that generally, although we're making huge strides in making these devices smaller, we need to do more to continue to minimize animal impact by making those physiologgers that record sleep smaller. But we also need the cyber infrastructure to help us translate what we find with those high-resolution loggers into the sort of species level patterns that we see, as well as across species and across fields. So that's really what is informing my research vision for the future, where I want to continue to build new tools for fundamental ecophysiology research. So that's heart rate and brain activity in new species. Build new tools for visual analysis that'll help us speed up our interpretation of that data. And then build those analytical tools into comparative systems where we can start bringing in the sleep patterns of an elephant seal and compare those to maybe a species that is of high conservation concern. And then visualizing those insights is something that I'm really excited about, and I think that that can build momentum for conservation as a whole. So for bioengineering, I feel like, even just the expertise that has just been shared, and by Phil, these secrets about, what is it, the capacitor that's creating the ultrasonic noise, or is it something else? There was something that I heard that super glue becomes conductive when it cures. These are the secrets that we need to be sharing with each other so that we don't run into these problems after it's been deployed on an animal. So yeah, we really need to find forums to share these expertise, these little nuggets of wisdom. So I've been developing some new tags during my postdoc. So basically translating the device for elephant seals to look at epilepsy in sea lions, to look at brain activity in freedivers, and then to improve the design for heart rate detection in baleen and toothed whales. But one thing that I've approached WILDLABS about that I'm excited for is the ability to lead a workshop where we bring these experts that have these nuggets of wisdom inside a room and really just document it. And that's our only purpose, is just to write down all the weird things that happen when you mix two compounds together, or when you put two loggers orthogonally to each other or parallel. We just get it down on paper first, and then we think about how to make courses for graduate students, undergraduate students, and sort of the next generation of the people who are going to build these physiologging devices or these advanced loggers that are smaller than ever. And then as a postdoc, I've also been part of this AI and Science postdoc fellowship, which has been mind-blowing in a lot of ways, but mostly because I realized I didn't know anything about coding. And through this program, I've learned a lot about coding in Python and how to begin to leverage AI. So for my dissertation, I manually scored 5.6 million seconds of data to the nearest second, which was thousands and thousands, probably millions of actual manual annotations of when these animals were transitioning between sleep states and respiration states and out of water, into water, etc. But that's really important. That manual process is really important. I mean, Lars was talking about the importance of a really good training data set. So it's not that time is wasted, but now how do we leverage that? So we've encountered this completely new species in a new context, and we've created a method for sleep detection. How can we use that to make an automated method to speed this up in the future? But this is going to cause some serious computational hurdles where the data itself is over 10 gigabytes. So the generated features from this kind of data set will easily reach 100 gigabytes, and they have to be stored in memory while you're doing the processing to train and evaluate a model. So that's where supercomputers come in handy. So I worked with 5 master's students who are here at UC San Diego that were engineering features for a flexible sleep scoring model that would be able to run on our data using the cloud resources in Nautilus, which is this free, institutionally run cluster that we have access to, that anyone has access to. And so they named this custom tool Marine Somniac, and it's built in Python, uses Streamlit. So it's a bit more simple than maybe an app that uses C or C++. So our hope is to make this an accessible research tool where you can visualize the automated sleep scoring data alongside the features, and you could switch these categorical labels out to be any sort of behavior state that is categorical. So we used a light GBM gradient boosted decision tree because that allowed us to rank our features and have a little bit more interpretability. And then we've been developing this tool alongside several other tools for AI and ecology. And I led this workshop earlier this year in March, where there were 5 different projects using AI for different challenges in ecology. And I think that this is where I see WILDLABS' potential to sort of facilitate this kind of innovation, this kind of bringing of people together. So we were able to get everybody together in a room for 3 days and create a bunch of useful software and think about how we can really leverage computation and AI in ecology. But mostly, again, I told you I knew very little about Python coming into this postdoc program. And since then, I've learned all of these fancy jargon things that have helped me become a better programmer. And I think that even though it can be frustrating for me to learn how little I know about Python, this type of training is really what's missing from the training of movement ecologists and what could really launch us forward. So I think that one thing that we're missing as a field is not only this computational training in AI, but also a shared data structure. And that can really help accelerate the innovations that we're making. So I've been making these Python tools for biologging data. And I don't know if any of you have tried to synchronize data to video, but there's no good tools, I think, that use open source software to do this. So we've been working on this Python tool that allows you to visualize time series data alongside the 3D model and video data that's associated with that recording. And it uses web-based framework using Dash and to display React components that are synchronized so that we can actually look at our data alongside the video. So this is an animal, a penguin in Antarctica that's swimming under the sea ice and comes up to grab some fish. You'll see it grab the fish. So this allows us to not only see the video paired with the data, which I think a couple of software tools allow you to export a video like this, but this is an interactive environment where you can decide to zoom in or decide to rotate the model to see it in higher resolution. And then I thought it was fun. This penguin found some Weddell seals fighting with each other over access to the breathing hole. So yeah, and then the app building, I've been also dabbling in making a mobile-friendly data entry app because entering metadata is one of the most painful things we do. And then I've created some documentation and tutorials. So we've created this structured DiveDB to house this type of data where you're using multiple loggers on the same animal that have multiple sensors that need to be synchronized and visualized together. And ideally, that would allow us to more efficiently label the data with these new tools. And then this is just an example, but we were able to get a pretty large data set into this database, about 300 gigabytes. And then that helps us query diving data much more quickly. So we can just select one out of these 655 animals and see the data from it. So our goal is to build this out for multiple data types and multiple species but we need WILDLABS help to do that. And we're really excited to work with people like this. And this will also help us visualize the data in this new Explorer that we've created. So you can go to our prototype now to check it out, but this is a way to show physiology alongside 3D movement and behavior really flexibly for different species, and just share your data with others in this format as well. So yeah, I think that's all we have time for. So I'll stop there.
Thank you so much. I think I speak for many or most people on this call and say that this is all so cool in a way that I've like never seen before. Like the chat is just blowing up with people being like, this is awesome. There are some questions for you in the chat. I want to be selfish and ask one first. What do you want people to come and talk to you about? Like if you get an email in your inbox asking about your work or asking to collaborate, like what is your dream scenario for what somebody comes to you asking for or wanting to collaborate on?
Okay, any of these 4 things, basically. If you want to build tags, contact me. If you want to build Python tools that leverage AI, contact me. If you want to help us do the really boring task of like, okay, this lab is using this MATLAB data format. Like, how do we map all of their metadata fields onto our metadata fields in our netcdf format? And you just build a little data input script, and then like that will unleash so much beauty and allow us to visualize all of that lab's data. So that kind of task would be really helpful. But if, it all depends on the skill level of people coming to me. If you're interested in biosensors, that's what I would love help on. We're using Python, Dash, React, Docker, so like expertise in any of those, and maybe some people who know MATLAB too, so that they can help translate between the languages would be great.
Awesome. And it looks like we had a question in the chat from Anne. Anne, do you have access to a microphone to ask your question? If not, we can ask it on your behalf.
I think I do. Can you hear me?
Yes, we can.
Okay, great. No, so Jessica, I work with an organization that does a lot of government contracts with the United States regulatory body in like the marine sector. So what they're always looking at is what kind of studies can we run and what kind of data that we can collect that will then tell us how we can regulate industry to reduce impacts to wildlife. And so I'm wondering, so a lot of what they do is, okay, let's tag animals, let's see where they go, let's see what their behavior is. And then do any of these certain behaviors mean they might be more at risk to certain industry activities or ship strikes or this sort of thing. And I'm wondering how you think this information applies, because what is new about this is the cognitive neurological processes that are going on in conjunction with the physiological behaviors. And I wonder if you think it has any application for understanding if an animal may be more at risk because of their, not only what they're doing physically, but their neurological state.
Totally. So yeah, I think we're still quite a ways away from being able to read the mind of an animal using EEG. That stands for humans and for animals. But we do have a lot of insights that physiology gives us that are even more simple to interpret. So for example, in this disturbance dive, this elephant seal probably hears something, although it can't be certain because we didn't have a hydrophone. But there's some behavioral change right here where the animal decides to extend its dive for about 10 minutes before it goes back to the surface. And that coincides with a drop in heart rate to 3 beats per minute. So if we can find these little instances where you could probably get that from the behavioral data alone, but then you get confirmation from the physiology to see that there's really an impact to the animal and maybe a decision switch that happens. So I think that building out these browsers to visualize the perceived sound at that animal's location, as well as potential sources of sound in the environment, it could be a really useful tool for what you're talking about, because there's, if I zoom out a little bit, there's a hydrophone that just sits on this slope over here called Mars, that's run by Mbari, and that data is right on this slope actually, that's run by Mbari, and that has access continuously to sound detections in its environment. And if we're able to model the sound that animal experienced, both using AIS ship data and that type of hydrophone data, we can really learn more about how to manage their habitats and protect their sleep, which I think is another interesting tool that these types of sensors will give us.
Yeah, that was one thing I was interested in, is are they more vulnerable if they're, say, asleep or awake, or can you monitor that or understand that maybe they sleep less if they're in an environment, say, where there's just a lot of noise due to industry or something like that. Anyway, they would absolutely love this, and they would also love the visualization from a communicating with the public standpoint. So I may contact you. I'll probably contact you later.
Yeah. So just one quick follow-up to that. This sleeping dive right here has a bunch of REM sleep, and then this is the disturbance dive where the heart rate went down to 3 beats per minute. And then the very next dive, the animal decides that it's safe enough maybe to go back to sleep, to have a bunch of REM sleep, to turn upside down, be paralyzed for 10 minutes and wake up. So that might tell you a little bit about maybe what it determined the disturbance, whether that was determined to be a risk or not. But I think that, this tool can help us understand the impact of physiology on behavior.
Thank you so much for that question, Anne, and for that answer, Jessie. We've got some more questions in the chat, but I'm going to direct you there to answer those questions about sensors. And we're just at time now. So I want to thank you all both for coming to Variety Hour and for our speakers for those awesome presentations from Lars, Seamus, Phil, and Jessie. I'm going to end the recording in just a few moments, but you're all invited to stick around for after hours to have a more casual conversation about the talks that we heard today and also anything else. So thank you again for coming. Happy Halloween, and we will see you next month. Bye.